this is Natalie Velasquez recording the concept map for our chemistry lab on lab number 1. Okay. So, from the bottom, I started with Dalton, who, of course, is the father of chemistry. Of course, the two branches of chemistry we have are inorganic and organic chemistry. All of chemistry is made up of elements, which can form acids and bases. Moving over to this side, I'm going to start bigger. Elements, I felt the ones that we had on our sheet, I decided to group them in ways I felt were related. So up here I have sodium, chlorine, sulfur, calcium, phosphorus, and is that it? Sodium, chlorine? Yeah, okay. So chlorine, of course, is used to make up chlorides. Moving over here on this side, we have oxygen, carbon, nitrogen, hydrogen, and phosphorus. These are mostly associated with organic chemistry in that these are some of the main things needed for life. These can make up groups of carboxylic acid, aldehyde, amino, hydroxyl, and carboxyl. These can all form amino acids which make nucleotides and form nucleic acids. Again, we know amino acids are used to form proteins, which then can form glycoproteins. We know that elements form compounds, which include carbohydrates, which are sugars. However, not all sugars are carbohydrates. Back to the compounds, we know compounds like fatty acids or lipids, which make up unsaturated and saturated fats. These can make up phospholipids, which are, of course, a type of lipid, and lipids form cholesterol. Back to the lipids, we know that glycolipids are also a type of lipid. Phospholipids either have a hydrophilic or hydrophobic tail, meaning they either do or do not like water. Going back to elements, we know that all elements are made up of atoms. All atoms have a molecular and atomic weight. The atomic weight is equal to 1 mole of that element. That mole is obviously equal to or related to the molarity. But 1 mole of that element is equal to Avogadro's number, which is measured in grams, which is a standard unit measurement that we have, which include meter, liter, and milliliters, which of course make up the liter. Going back to the atom, we know that they're either electron donors or acceptors, which then make ionic bonds. These include both the cation and the anion, and cations are used to make salts. All atoms have a nucleus. The nucleus contains a proton and a neutron. The proton is the same as the atomic number, so whatever the atomic number is for that element, we know that's how many proteins that it's going to have. Neutrons make up isotopes. Isotopes, of course, include radioisotopes and water isotopes. Every radioactive isotopes have a half-life. And every single one does have a half-life. The half-life is just the amount of time it takes for it to become half the mass it was when it started. So nucleuses are surrounded by electrons, which are held in electron shells, and the last shell holds the valence electrons, so those are the outermost electrons of the atom. Electrons make up nonpolar covalent, polar covalent, double covalent, and triple covalent bonds. Polar covalent bonds make up water, which makes up hydrogen bonds, which then have cohesion and adhesion. Sorry, I can't talk today. And yeah, that is my chemistry concept map.